Okay, this video is to help you review for your midterm. I may have to make it into sections because I don't want it to run too long, but let's go ahead and get started. Question number 1. Fill in the blank so that the resulting statement is true. I think that's just a vocabulary question, and everybody knows that those are the answers for classifying angles. Find the radian measure on this one. You're going to use the formula S equals R theta. You're going to plug your values in, divide both sides by 100, you get 70 over 100, and you simplify. You can simplify in your calculator. If you do 70 divided by 100, it gives you a decimal. You can press math, enter, and it will give you, I don't want to inverse, 70 divided by 100, math, enter, and it will give you the answer. Convert the following angle in degrees to radians. So you're going to multiply degrees by pi over 180. Same process. We're going to simplify that. 40 divided by 180. And we'll hit math, enter, and it'll give us 2 ninths. And we know it needs a pi in there, so it's 2 pi over 9. Convert the following radians to degrees. So if they give you radians, you multiply by the reciprocal of that, which is 180 over pi. The pi's will cancel, and we have 7 times 180, and we divide that by 5, and it gives us 252 degrees. Find a positive angle less than 360 that's coterminal with the given angle. You just subtract. 1 trip all the way around is 360, and it would be 95 more degrees. So that's just a subtracting problem. Question 6 says find the length of the arc S on the circle of radius R intercepted by central angle theta. Express the arc length in terms of x, then round to 2 decimal places. So they give us R, and they give us the central angle in degrees. So the first thing I do is I take my degrees and I convert it to radians. So theta is really 5 pi over 9, and then I plug that in. And I do my calculation, and I want my answer in terms of pi, and I get 10 pi over 3. And then, if we want that to be turned into a decimal, we just put that in our calculator. Number 7, fill in the blanks. This is from the cofunction. Remember that you are allowed to have your identity sheets when you are taking your midterm and the unit circle, and this is the cofunction identities, which would be here. And you just need to remember that 90 is the same thing as pi over 2, and that's where we get those answers. The first one is sine, the second one is tangent, the next one is secant. Number 8, use the Pythagorean theorem. So just a basic Pythagorean theorem question. We get 20 for an answer here. And then you need to use your trig ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. None of those simplified, so this was a pretty straightforward question. The reciprocals of those are here, and that's just your hypotenuse over your opposite, and your hypotenuse over your adjacent over your opposite. Once again, I'm going to the reference sheet, and I'm getting those ratios from there. Okay, it says use the given triangles to evaluate the following expression. If necessary, express the value without a square root. So they want the cotangent of pi over 6. So the first thing I did was I converted pi over 6 to degrees, and I multiplied it by 180 over pi, and I simplified, and I got 30 degrees. So I knew I was going to use this triangle, and 30 degrees was the angle that I was most interested in, so I put my smiley face there. From smiley face, this is the opposite, this is the adjacent, and this is the hypotenuse. So the cotangent is the adjacent over the opposite, so I grabbed those numbers, formed my ratio. I didn't have to do any simplifying, and that's my answer. 10 sin theta is an acute angle. Sine theta and cosine theta are given. Use the identities. It says to use the identities, but I like to use these. You know that sine is y over r and cosine is x over r. So sine y is 21, r is 29, x is 20. If you know x, y, and r, you can find all these ratios, and that's what I did. I just used that to form those ratios. Find a cofunction with the same value as the given. Secant of pi over 2 minus x is the same thing as cosecant. Well, remember, pi over 2 is the same as 90, so I use this version with the 90, and I subtract 41, and I get secant of 49 for number 11. Number 12 asks you to find the value using your calculator. Please go to your calculator and put it in degree mode for this problem. If you have it in radians, it will give you the wrong answer. After that, it's simply just typing it in and rounding it off appropriately. Number 13 says find the measure of the side whose length is described here. So I have an angle here that I know, so I put my smiley face here because I want everything to be done in reference from this angle, which makes this the opposite and this the adjacent. So if I'm using opposite and adjacent, I know that I'm using the tangent. So the tangent of 38 is opposite over 320. I find that value using my calculator. I'm in degree mode still because this is degrees. And then I simplify my equation or solve my equation by multiplying by 320. It says round to the nearest whole number. 14 says find the exact value. I'm going to go back and use that same cofunction identity. And this, I noticed that 65 and 25 are complementary angles. So the sine of 65 is equal to the cosine of 90 minus 65. If it applies to the degree 1, it also applies to degree 2. So I can replace sine of 65 with cosine of 25. So that gives me this. Then I can take these using my there's a Pythagorean identity, and I can convert that to 1, and 4 plus 1 is 5. 16 is an application problem. This is the angle that I'm given, so I'll put my smiley face here. This is my opposite and my adjacent. Once again, make sure your calculator is in degree mode, and you just solve. Evaluate the trig function at the quadrantal angle. You're using your unit circle, and pi over 2 is here, x is 0, and y is 1. Tangent is y over x, which is 1 over 0, which is undefined. If you go back and you put this back into radian mode and you enter this on your calculator, pi over 2, it will tell you that it's undefined. So if you put your calculator in radians, but you need to be able to go back and forth. Find the reference angle for 7 pi over 7. Well, I know that that's a little bit more than 1 pi, so 7 pi over 7 is pi, and then it's an extra 3 pi over 7, so that is my reference angle. I think I said that wrong. What's 10 pi over 7 is the angle we're using. 18. Find two values that satisfy the following. Okay, sine is the square root of 2 over 2, and sine is y over r. So r is equal to 1 on the unit circle, so I'm looking for places where the y value is the square root of 2 over 2. And that happens that happens here, and that happens here. So I'm looking at 3 pi over 4 and pi over 4 for my answers. 19 says a point P is shown on the unit circle, and r is 1, this is x, this is y. Find all the functions. So I'm going to go back. I'm going to use this little set of functions, and I'm going to use all my ratios. Once you get the first 3, you know which ones they pair up with. They're just reciprocals. Determine the amplitude of the function. Amplitude is the absolute value of a. A is found here, so it's the absolute value of -7, which is 7. Okay, when they ask you to graph, your calculator will help you graph these. So I want you to go to y equals, put your equation in, and then I want you to go to zoom. And I want you to go down and I want you to choose trig. Okay? Now, look at that window. That's a crazy looking window. Let's make sure our window is correct. This window goes from negative 2 pi, and the x maximum is 2 pi. The y minimum is negative 15, and the y maximum is 15. You can leave the others the same. Once you change your window to match the window of the graph given, you can sketch your graph right there. You can see where it hits 0, where it hits 1. You can see all the or 7 in this case. You can see all the values there. Number 21, I've got this in my calculator. It's asking for the amplitude, which is the absolute value of A, which is 7. It's asking for the period, which is 2 pi over B, and B is 4 pi here, so that turns out to be 1/2. And I've set my window up so that it matches the window given here, and when I graph, it'll give me my picture. So you can use this as a tool to help you graph. 22, determine the amplitude, the period, and the phase shift. The amplitude is the absolute value of A, which here is 4. The period is 2 pi over B, or B over 2 pi over B, and B is 2 pi, so it's 2 pi over 2 pi, which is 1. The phase shift is C over B, so that would be 2 pi over 2 pi, which is 1. And you can also go to y equals and set this up and graph that one. Graph 2 periods of the given tangent function. You can do this one on your calculator as well. So I go to y equals and I type this in, and then I hit zoom and I go to 7 for trig, and there we go. And we see that this one, we can check our asymptotes and we can see that it matches answer choice D. Question 24 asks you to match some graphs of cotangent. Some are positive, some are negative. So I went to the textbook and I wanted you to see this. This is our cotangent. So if cotangent goes this way, negative cotangent goes this way. So you can eliminate, or you can sort these, and you can pick out that these are positive cotangent, and then those would be negative cotangent. So that's number 1. Now how do we get the specifics of those? Well, we got to find the asymptotes. The period of the cotangent is between 0 and pi, so we find the asymptotes, and when we do that, we figure out that this is our negative cotangent, and this is our negative cotangent of x minus pi over 2, and this is the cotangent of x plus pi over 2 and x plus pi. So you can use your asymptotes to help you determine which one matches which. So they're asking us in number 25 about the domain of cosine inverse. And so here we go. Here's the cosine function. You can see that the domain of the cosine function is 0 to... The domain of the cosine function is 0 to pi. So if that's the domain of cosine, that's going to be the range of cosine inverse. So the range of cosine inverse is 0 to pi. The domain is the range here, and the range of the cosine function is from negative 1 to 1. So that becomes our domain here. So the domain is negative 1 to 1, and the range is 0 to pi. 26 says, fill in the blank so the statement's true. Sine inverse of sine x is equal to x for every x in what interval? Well, sine inverse has to have a restricted domain from negative pi over 2 to pi over 2. So that is our answer for number 26. Number 27 says, find the exact value of cotangent inverse of square root of 3. Remember that tangent's y over x, cotangent's x over y. So if it's the square root of 3, your x value is the square root of 3, your y value is 1. If you go to your unit circle, you'll find that that occurs at pi over 6. Solve the right triangle. So we label A, we label C, we use sine to find the missing A value, we use cosine to find the missing B value. We simply subtract from 90 to find B's value, and C, of course, is 90. 29 says find the length of x to the nearest whole number. So I work each of these triangles separately using 50, tangent of 50, opposite over 450. I solve and I get this number. I use tangent of 26 equals opposite over 450, and I'm solving to get this number. When I add them together and then round at the end, I get 756. Number 30, you're going to have to separate these triangles. You're going to have to separate the smaller one here, and then you're going to use the entire triangle over here. And once you separate them and set them up, and you solve tangent of 62 and tangent of 31, solve these independently, and then you're going to look back. The big one, the entire thing, this entire part I'm calling M, and I'm calling this little part question mark. When you get done, if you do M minus question mark, you'll be left with the X. Okay, now this has been a very quick video. This is exactly the same kind of questions you'll see on the midterm. So I hope that you'll watch this and that you will do well.